So we could use Matlab to solve problems, linear equations. So we have three linear equations in here, as you see in here, three linear equations. So we'd like to know the value of x, the value of y, and the value of z. So let me comment these linear equations, these equations. These are the linear equations. I'm commenting them right now. All right, how to solve it? So how to solve these linear equations? So we could create a matrix A of the coefficients A, which will equal, okay, 3, 2, and minus 1. So 3, 2, and minus 1 for the first equation. And for the second one, it will be minus 1, 3, and 2. Minus 1, 3, and 2. And for the third one, it will be 1, minus 1 in here, and minus 1. It will be 1, minus 1, minus 1. So these are the matrix of the coefficients. And for the variables, let's save it in x. Okay, so it will be x, y, z. X, y, z. And for the other side, in here, for the end of the equations, we could call it b. Could call it b. So b equals, all right, equals to 10 and the 5 and the minus 1. All right. So this will be, let's run this. Okay. Yeah, I forgot to put the equal in here, so let's run it again. And this is the A. The B equals, okay, so in here x, so let me comment this for now. Okay, comment this for now. So anyways, so we have the three equations in here. We took the coefficients of the first side, we made it in one matrix, and we took the coefficients of the other side, we make it one matrix. All right. And we know that now, we know that um, a times x will equal b, will equal b. All right. And we know that a to the power minus 1, which is the inverse, minus 1, okay, um, times a equals 1. So now we need to move a to one side. We need to move a one side. So all we have to multiply it with the coefficient. So we know that x equals a to the inverse of a, times b. All right, and then we'll be able to find the values of b, the value of values of b. All right. So what we do, we created a, we created b, and then we need to create the inverse. Okay, we need to create x. Okay, so we have a, we have b. X will equal to the inverse the inverse of a, okay, which is in here, the inverse of a, okay, multiplied by b. All right, and let's run it. So these in here, let me remove them right now. Okay, let's run it. B. So inverse. So it's let me remove this one in here as well. So inverse of a multiplied by b. So we have a in here, which has the coefficients, and here we have the b, which is the other side of the equations, and then in here we have the solutions, the x. All right. So x is -2, y is 5, and z is equals -6. So you always could solve a set of problems this way. You could solve a set of problems this way. Regardless of the coefficients of the equations, just put the coefficients in one matrix and the results in one matrix, and use the inverse of a multiplied by b, and that will give you the results. So you could use it to solve a problem.